So today we will focus on the GPT-3. Actually, the title for the GPT-3 paper is not GPT-3. It is Language Models for Few-Shot Learners. So you can see that the focus is on the few-shot. GPT-3, I think, is a very important milestone in the LLM world because all the current, at least on the OpenAI threads, the GPT-3 is one of the most important foundation model for them. And a lot of later developments are extensions to the GPT-3. So before diving into the details of the models and the results they find, let's look at what's the applications of GPT-3. So first, immediate use case is a chatbot, just like the ChatGPT, right? So you can actually ask any question to the GPT model, and then you got a response. And then people actually are testing to see whether the GPT model can pass the Turing test. Basically, is that based on the responses you see, can you distinguish whether it is a machine replying to you or it is a human reply? So I think some of the tests show that, oh, the latest, greatest LLM model already passed the Turing test. But again, I think that depends on how long the conversation you have, right? Because the longer conversation you have, the more likely that it may not utilize the full context very well, and it may lose track to follow the conversation topic. The second application that people build is quite amazing and useful is the summarization. So here is you can just input like, for example, a paragraph from GPT-3 paper, right? It's very technically and scientifically written. And then you ask it to explain it in a simple way. Actually, the name for this app, I think, is like explained to a 5-year-old. So you can paste any complicated text here, and then it translates it into like shorter sentences, easy to understand, right? So what this GPT-3 is about. So basically, if you make a language model with more parameters, it will be able to generalize better to new task better. Yeah, so I think it's a very cool applications as a learner assistant for you to kind of understand what that technical paragraph is talking about. People have also using the GPT type of models to build apps. Basically, just like the you use it to generate codes, right? So right now we rely on the humans to write each line of the code, but with the GPT-3 or LLM model, you can just input a description, right? So I want a button, I want a input, say enter a to-do list, and then a button says save the to-do, and then show me all the to-dos. And then you click generate, and then it will generate the codes for React, and you can directly see the effects of the generated codes. So it's more like writing the programs in a more natural language way, rather than you need to learn how to write React codes to build this web app. There's still a way to go of how we can further automate the code generation. But when the GPT-3 comes out, people already start testing, okay, whether it can help me write codes effectively. And now what I need just to do is just to test it out to see if it works. So these are all very cool GPT-3 applications at that time, and also very cool applications right now for the LLM model. I think it will be very interesting to looking at the history from the transformer, which is the original paper proposed the transformer architecture, which basically serves the foundation for GPT and for all the LLMs right now. And then to see like how it evolves from the transformer to the GPT-4, which is the most effective model right now from OpenAI. So from the transformer model, you see it's published in 2017. So it proposed the transformer model with the attention mechanisms. If you need more details on transformer, I think you can look at the blog that I have written. I will share the link in the chat later. And then about a year later, two popular models based on transformer is proposed, which is the BERT model. It's like a bidirectional representation model, and the generative pre-trained model, GPT. So this model at that time is small. It's just like 100 million parameters. And it just directly takes the decoder part from the transformer and then use the pre-train and fine-tune schemas to adapt one model to different tasks. But you still need to kind of fine-tune it on that task-specific data sets to get your GPT model. And then less than a year later, OpenAI also published a GPT-2, which is like more than 10 times the size of GPT-1. And it focuses on the zero-shot performance. So they call it like unsupervised multitask learners. So original GPT-1 is fully fine-tuned, right? So it's supervised multitask. And then GPT-2 becomes unsupervised multitask, which means that you do not require any labels for a new task. You just directly give the task instructions, just like what we are, how we are talking with ChatGPT right now. You just directly gives the prompt for the task instructions, and then it gives you the prediction outputs. So at that time, even though it's like 1.5 billion, it already shows some of the promising results for some tasks. And then another, like more than a year later, they published GPT-3, which has the 175 billion parameters. It's almost the largest model at that time, and also one of the largest. But I think right now most LLMs are passing the 175. And this model will focus on the few shot learners. So from the zero shot, it moves down to few shot. But the few shot is like in context few shots. Basically, along with the instruction you provide to the model, you also provide in-text examples in your prompt to the model so that the model can gain a better performance with that. So this is mainly GPT-3, which will be the focus of our talk today. And then later, about another a year later, they published the GPT 3.5, also called Instruct GPT. Actually, so over 350 billion parameters. I think this is a guess that I got from the internet. I don't think they have disclosed like exactly how many parameters it has. So this is kind of an estimate of how large that model is. What it has in here is it overcomes some limitations of GPT-3 by aligning the outputs of the model with the human feedback through the reinforcement learning framework. So it's mainly focused on the human alignment part of the model so that we can de-bias the model and also guide the models to generate human preferred output. So about 8 months later, after the Instruct GPT is published, the Chat GPT is released. So kind of that really create kind of everyone just want to try it out. So you can see that how ChatGPT is born. ChatGPT is just the application, but behind the scene, it's actually all these models, right? And it will gradually evolve better in the zero shot, few shot, and also align with human better, and that give birth to the ChatGPT application. And then finally, like earlier this year, they also released the GPT-4 technical report. And again, another guess is the model size reaches 1.5T to 1.8T. Another kind of almost 10 times comparing to GPT-3. And this time it focuses on the multimodal, which means that it does not only takes the text as the input, it also takes in the images as the input. Okay, so here's an overview of that. So before moving to the GPT-3 model, so I want just to give a brief introduction to the GPT. So the GPT is basically just always predicting the next token, right? So this is your, say, your prior sequence before the word you want to generate next. And then basically for each word, the model is going to represent each word with a vector. And then it passes through a stack of decoders. So these are transformer decoders. And then it will generate another vector, which is used to generate a probability for each word. And then you can use that probability to pick the highly likely word that are predicted based on this prior sequence. And within each decoder, the most important submodule is the mask self-attention. Intuitively, you can think of it as basically for each word, it's going to attend to all the previous word, right? So it wants to learn a contextual representation of this word. For example, it over here, what it refers to. So basically the model will automatically learn that the it here should attend to a robot, right? So that's the meaning of the it. So through the attention mechanism, it will automatically learn like what's the meaning of the word given the context better. Well, the mask over here means that it can only attend to the previous words. Without a mask, like in the bidirectional setting, it can attend to all the words nearby it, including the words like after it. So that's like unmasked, a bidirectional attention. Well, with a mask, like the GPT generative type of model, it only attends to the words before it. That's the intuition of the GPT. So let's look at the GPT-3 model architecture and how it kind of got updated. I think it's minor, small changes, updates to the prior GPT versions. So this is the GPT-1, also the direct decoders from the transformer model, right? So you have these embeddings, and then you pass through the self-attention, and that the layer norm, feed forward, and of course you have these residual nets, right? So this is like a residual skip connection, and then the layer norm. When it comes to the GPT-2, there are mainly these three major changes. So one is the layer norm. Layer normalization was moved to the input of each subblock. So instead of like the layer norm is put over here, it moved the layer norm before each submodule. So it tries to normalize the input to every subblock in the decoder module. And the second is like they scale the weights of the residual layers at initialization by a 1 over square root of n, well, n is the number of residual layers. This is some just empirical observations that I observed that to avoid the cumulative effects. Like if you have like n residual layers, if you just keep without this like trying to make it unbiased estimates, without this you may over kind of like an overestimate of that. And also they extend the vocabulary to cover 50,000 words and also increase the context, double the context there. And this is a GPT-2. And GPT-3 is another minor, I think it's almost a major change based on the already existing minor modifications on GPT-2, is that it adopts a new attention pattern. They also call it a sparse transformer. So what is sparse transformer? So you can think of it as originally the transformer for each word is going to attend to all the words before it, right? So for example, for this word over here, it's going to attend to all the words before it. And right now for the sparse transformer, it will only attend to a few words before it, and then it will attend to a token by a certain skip, right? So for example, you attend to this word, and then you skip 3 words and attend to this word and skip another 3 words. So it's kind of like a sparse attention instead of this dense attention. So this way it can save some parameters and also increase the learning. At the same time, do not decrease the scope of attention. You still attend to lots of like a long sequence before it. It's just like it uses a much sparse attention in the attention calculation. So that's GPT-3. Yeah, question?
I'm actually like, I'm not an expert or anything. I'm just learning as well. So, but I have a question. Is that what, like, because of the sparse transformer is word that you don't give much attention, that you get all the hallucinations? Like they say, like it keep on, even if there is, if like if I ask a syntax of a language, even if it isn't like a program or something, sometimes it gives like weird answers, right? So it's not even true. So the hallucinations is because of the sparse transformation, or that's completely unrelated.
No, and
Okay,
that's not related to that.
got it. Okay, thank you.
Okay, and moving next to GPT-3, in the paper, actually GPT-3 includes a different model sizes. So it has like a GPT-3 small with only 125 million parameters to the largest GPT-3, which have 175 billion parameters. Basically all these models use exactly the same architecture, and what conclusion they want to make is they want to compare the model performance across a variety of NLP tasks, and with an increasing model size, say from this just 100 million to this the largest 175 billion. And you can increase the model size by first increase the number of attention blocks. Original transformer also have 12 layer, 12 decoders stacked in the GPT model. So that's original 12, and then you can see that it uses like more decoders blocks, like 96. The dimension of the model, which is like how many, what is the vector length to represent for each token. So the longer is kind of like the more complicated patterns you can learn for each word, and the more meanings you can capture. And then this is the attention heads. Basically a variety of attentions that you can learn in parallel for each word. Dimension of the head, basically just do a division of this dimension of the model divided by the dimension, divided by the number of attention heads. You get your dimension head. The batch size and learning rate is used in the training schedules. So people actually find that it's more effective or get a better performance when you use a small learning rate, but with a large batch size. So that's why you can see like a GPT-3, even though the model is the largest, but it uses the smallest learning rate comparing to the previous like even smaller model, but it used like a really, really large batch size over here. So that is the main configurations of the models. And the next I want to focus on what GPT-3 is really focusing on. So what is the main scientific contributions that GPT-3 brings? What it focuses on is the in-context learning. So how is it different from the traditional fine-tuning schema? Is that originally like not like the GPT-3 or the model. Originally, when we have examples, for example, this translation over here, like English to French, right? You need to update your model parameters, right? So there will be a gradient update once the model sees the training examples. So you're going to update the model parameter weights according to the training examples. So that is the full fine-tuning of the models given the training samples. While in the in-context learning is that you will just freeze the model. So once the model is trained on a large corpus data sets, like pre-trained on a large corpus of data sets, that model is going to be frozen And then next, when you want to say want this model to adapt to a new task, say translate English to French, so you just give the description, and then you give the prompt, right? So this is English, and then you directly ask the model to generate the output. So this is a zero shot without providing any examples. And then you can also provide the examples, which they call is the in-context learning, is that you provide examples in your prompt, right? So I can give some, like, for example, it gives some example here, and then it gives the prompt that asks for the output. So this is one example. And again, you can give even like multiple examples, like for example, 3 examples here. And then you ask the model to generate the predictions. So GPT-3 wants to try this framework out across different NLP tasks to see that first is the model size, right? So with a really large model, how much performance gain it can get. Second is with this few shot in context learning, by providing these examples in the prompt to the model, how much performance gain you can get. So that's the conclusion that the GPT-3 wants to get. Before getting to the final results across a variety of NLP tests, so let's also look at what training data sets that the GPT-3 use and how it's evaluated against different tasks. So they use like mainly 3 public data sets to train the GPT-3 model. So this training is mainly the generative pre-training. It means that you just give the prior sequence of the words and then ask the model to predict the next word. And then you want to maximize that probability of the predicted word versus the word you actually observe in this data set. So you see that the largest pre-trained data set is the common crawl data set. So this is the one openly crawled from the internet. So original is even bigger, like after filtering is like 400 billion tokens. And also Wikipedia is 3 billion, although Wikipedia, I saw is already very big data sets. And then, so here, they train the GPT-3 models for 300 billion tokens. As a result of that, they want to give fair exposures to different data sets, which ending that they only use like for the whole training tokens, only 60% of the training tokens from Common Crawl and 22 from the web text tool and 3% from Wikipedia. And as a result, because the Common Crawl has a lot of tokens in it, as a result, it only sees like about 0.44 portion of all the tokens in the Common Crawl. So about 44% of the Common Crawl tokens are actually used in training the GPT-3 model. While the Wikipedia, since it's the smallest data set over here, actually it's triple. So all the tokens in the Wikipedia are seen more than 3 times in the training tokens for GPT-3. As we know that the GPT-3 focused on the few-shot learning, so the evaluation is also focused on the few-shot learning. It basically just evaluate each example in the evaluation test by randomly drawing k examples from the training set. Because it doesn't require the full fine tuning on the training set, it just uses a very few examples from the training set as the in-context few-shot examples. And then again, based on like how many examples you can give, that is limited on the context length to the model. So the context length is limited to 2048. So which typically can only fit 10 to 100 examples, but they also find that larger values of k, larger number of examples are usually not always better. So maybe 3 examples for some tasks is already sufficient. And also for the task with the free-form completion, which means that maybe you ask the GPT-3 to write a poem, right? So it's like a free-form completion. It used the beam search with a beam width of 4 and also a length penalty of 0.6, so that you want to have some appropriate length output, and again with some freedom of search of a beam search of for. So you can easily search a beam search on Google and get what it does there. So basically, it's not a greedy search, but you keep the, for example, keep the best 4 possible generations from your search instead of just keeping one output with a greedy search. And let's look at some examples of how they prompt the GPT-3 model. So here I think it's more like a reading comprehension Q&As, right? So you have your title, the context, which is like title and also paragraphs, and then you ask the questions. So basically, the answers can be found from this paragraph context. And then you give one example, for example, over here, and then you prompt the model to answer the second question. So here, like instead of just doing like the free answer, you can also prompt the model to give the answer of true, false, or neither, just providing the exhaustive options, kind of like the optional multi-option answering task. So you can provide these answers and ask the GPT-3 to give the exact one you want from here. Okay, then let's move on to the results of GPT-3. So in the GPT-3 paper, a really large portion of the paper is on discussion and showing all the results like across many different type of NLP task, which includes a completion task, the open closed book question answering, like just like a general knowledge-based QAs, translation task, common reasonings, reading comprehensions, natural language inference, etc. So like a variety of different tasks. And this is a few shot performance they put. And again, this few shot performance is compared to the state-of-the-art fully fine-tuned model. Even though for some of the tasks it says like good or very good, maybe there's still a gap to say human level performance, right? So actually the performance here is compared to a fully fine-tuned state-of-the-art model at that time. So this shows the aggregated performance of GPT-3 along the model size. So the x-axis is the model size from the like 100 million to the largest model size, and then the y is, you can think of it just as the accuracy. And then you can see the blue line is the 0 shot, green is the 1 shot, and orange is the few shot. For example, like 3 examples few shot. And of course, like these lines will vary a lot based on what task it has. And it just do aggregated average across all the tasks. And then you see the aggregated performance. So actually you see that there's already a performance jump from 0 shot to 1 shot, right? And then there will be another kind of some improvement, additional improvement if you provide more examples in your prompt to the model. And then let's look at like more specific NLP task. So the first one is the completion task. Completion task is like this, right? So you just give like a very, like for example, this one sentence here. Basically just like a one sentence with one word missing, and then ask the model to predict the next word. So yeah, so based on the context given, right? So what is the predicted word over here? So you see the GPT model, like especially on this Lambda dataset, it already like beats the state-of-the-art accuracy over there. And for the other similar data sets of completion, it is also close to the state-of-the-art fully fine-tuned model. But this one is this one, I think this is another like a evaluation matrix. What is the PPL? It's another evaluation matrix over there. Another task is a closed book Q&A. So closed book Q&A is you just directly ask a question. For example, where was Bill Gates born? Some like open question like that without providing any context information. Just by because the GPT-3 has already seen lots of data through the pre-training stage, such as Wikipedia, right? So they just want to see what's the GPT-3's performance on this like publicly available, like this common knowledge questions. And then they find that the GPT-3's performance actually beats the state of the art, like especially for the closed book, which means that you do not provide any context information. You directly ask a question and get a response. You see that it's already improving, comparing to the at that time the state of the art closed book fully fine-tuned model. And also if you look at the chart, so especially for the trivia Q&As, you see that the few shot when K is 64, which means the K is like providing 64 examples over here, is already beating the fully fine-tuned state-of-the-art model at that time. Another task is on the translation, right? So you can translate English to French, French to English, and also English to Germany and German to English, etc. And again, you evaluate what is the performance. And they find that actually the performance is a lot better when it's another English translates to English. Right? So for example, if it's France to English or Germany to English, actually the GPT-3 few shot performance is very good. It's beating the state of the art at that time. But if it is the vice versa, right? So you translate English to a non-English language, the performance cannot the few shot performance cannot beat fully fine-tuned supervised model over there. Yeah, so you can see.
What is state of the art supervised? Is it what is a supervised here means? Is a supervised learning? That's the
Yeah, so basically it's like you design a specific model that is trained on lots of English French peers.
Got it.
For the translation. Yes. And over here is like you haven't seen such task before. You are not specifically trained the GPT-3 for the English French peers like that. Yeah. So they want to really see like how the future performance is compared to the fully like supervised trained model at that time, where they have seen basically they've seen all the English French peers like for translation task and train that model to get the performance. Well, the GPT-3 is only pre-trained like a large text corpus, right? It's not specifically trained for translation, but it's very interesting to see the few shot performance already beating some of the state-of-the-art supervised translation model at that time.
So they're comparing the state-of-the-art supervised learning model with GPT-3, which is unsupervised learning model, and seeing where's the difference.
Yes.
Thank you.
Yeah. So basically, the conclusion they got is they can be competitive with the supervised state-of-the-art when translating into English, which means that GPT-3 is actually good at generating English language, but not very good at like generating non-English language. Basically, like translating from another non-English to translating from English to a non-English language. I think that is because of the pre-training data sets are dominantly by English. So I think the GPT-3 model is better at generating English text than non-English text. Another task they evaluate is the common sense. The common sense is, here's the example. The PQA dataset is the physical interaction question answering. Yeah, when I look at this, it's like I'm really amazed of how people formulate the Q&As for MR models to test out its capabilities. Example is this, right? So you ask the model to separate egg whites from the yolk using a water bottle. So how should you do that? And you provide it with the two options. If you read this, if you think well, you may think, oh, maybe option A is feasible for this to complete this task. So basically, it will prompt the model to use some physical prior knowledge to reach to a good answer for this question. So that's like a physical common sense reasoning task. So that is PQA. And then you see the GPT-3 actually performs very well comparing to the fully fine-tuned model for that. But for the other of the task, the other like easy challenge or open book Q&A is still farther away from the state-of-the-art models. So for common sense reasoning, it's really task dependent on what task is given. So it may excel at some task for the few shot, but for the other specific task, there's still a big gap, like 51 to 78, comparing to a fully fine-tuned model. The reading comprehension task, strong on COQA dataset, but also weak on the others, just like the case before. That it's strong, it shows promising results on one dataset, but it still falls behind on the other similar datasets. For example, on the co-QA datasets, so again, this is the 0 shot, 1 shot, and few shot. Few shot here is that K gives 5 examples over here. And then the fully fine-tuned state-of-the-art is even beating the human performance on this task. And you see it's getting closer. It's getting close, but not beating the state-of-the-art yet. This is an example of what the data set looks like. So basically, you give a paragraph to read, for the model to read, and then you ask a question like who had a birthday, how old would she be, etc. And also you provide the answer and also the rationales of giving that answer. So you need to identify which sentence in the original paragraph will indicate your answer. So basically, you give both the answer and the rationale for the answer over there. So your prompt, you provide, for example, 5 examples, right? So 1, 2, 3, 4, 5 examples, and then you ask a new question, another question, and then ask the model to give you back the answers and the rationales. Yep, so that's a reading comprehension. Another very kind of like the NLP benchmark for natural language understanding is the SuperGLUE dataset. So the SuperGLUE stands for a super general language understanding evaluation dataset. And this dataset, so this is the SuperGLUE average. And actually this SuperGLUE datasets consists of a variety of different tasks. So each column here is a dataset in SuperGLUE. It's a different task in SuperGLUE. It contains bool prediction, like true or false. It contains like multi-option prediction, and all different types of predictions over here. For example, the COPA dataset here, which the GPT-3 few shot is good at comparing to the state of the art, is you give the premise of what is this, and then you give like alternative 1 and 2, and ask the model to decide what should be true. For example, what was the cause of this? Like broke his toe. Like is it because alternative 1 or because alternative 2? Like which cause the man broke his toe? So it's kind of the option selection task. You ask the model to generate. So actually, they generate It's like a variety of different tasks, and then they do an average across different tasks, and use the score as a representative number for the language understanding for that model. So you see over here, like the fine tune at that time, the state of the art is closer to the human performance. And also the BERT model, the fine-tuned BERT large and plus model over here, at least we see that GPT-3 few shot with K equals 32 examples provided in the prompt is beating the BERT model at that time, fully fine-tuned BERT model at that time. They also evaluate GPT-3 on the arithmetic task. So it includes a 4 to 6 digit addition and subtraction. Very interesting phenomenon they observe is like if you do not place a commas in the digit, you just directly do the plus. Actually, the accuracy is very low. And then people identify that if you actually add a comma to your numbers, the accuracy improved by a lot. So nobody knows why. Maybe that's how the numbers is represented in the pre-training data sets. So that's kind of like a format you need to follow in order for the model to work well on that. And this is discovered by someone. So, and then they find out, oh, just by reformatting the data sets can already gives you a boost in accuracy of addition and subtractions of 4 to 6 digits. They also tested out the generative capabilities of GPT-3. Basically, it asked the GPT-3 to write a news article. So for example, you can give it some certain topic, right? And maybe give it a few facts, and then let it to formulate a news article. And then they ask the human, and then basically they mix the output with the actually human written news articles, and then ask another human evaluator to see whether that article is human written or not. And then they actually find that with the GPT-3, the largest GPT-3 model, it's getting closer to this random chance, like 50, kind of like a guess, like human just directly guess, like whether it's a human written article or not. I mean, it means that the quality of the generated article is very good, that it cannot be distinguished from real human written news articles there. So it's getting close there. So that concludes the like a model performance across different NLP tasks. They also talk about the limitations of the GPT-3 model is that right now there's no alignment or de-bias happening with the model. So this model is biased and also is tend to reflect stereotypes present in the training data set. So for example, if you prompt a regional GPT-3 model and ask it to show the 10 most favored words about each religion, it may give some like unpleasant outputs over there. So that's why, like after GPT-3, OpenAI has also spent invested lots of efforts, and I believe that is true for all the LLM development right now. Is trying to figure out how we can avoid the stereotypes and de-biased the model, even though the training data sets may be biased because the internet data is biased. But we should unbias the model as best as we can. So that kind of concludes what's the GPT-3 strengths and weaknesses that is reported in their paper. It shows like good at completion task and also open book. I think this is a closed book Q&As, and also we see that it's beating the state-of-the-art fully fine-tuned model for translation task from non-English to English. But it still like has mixed performance, which means that it only getting close to the state-of-the-art performance on one or two of the data sets, but falls far behind on the other similar data sets. So it's like a mixed performance. But for some of the tasks, such as natural language inference task to predict the relationship of the sentence, etc. And also the bias issues is really poor. So it's kind of the opportunities to further improve the GPT-3 by the subsequent models like the instruct GPT, for example, to migrate the bias issues. And this is a final conclusion slides. I hope that you walk away with a message of how basically the history development from the transformer to the final GPT-4. And you see that at each stage, it mainly focuses on one area of the model. Right, so the first one is on the architecture. The second one is on the pre-train and fine-tune, like using one model, using the same exact model, but they can pre-train and fine-tune it to different NLP tasks. And then they focus on the zero shot to see the possibility of zero shot, and then they further extend to few shot, in context few shot. That's GPT-3 that they show improvement over the zero shot without providing any examples in the prompt. And then later on, I think this is for our upcoming LLM reading group, is the instruct GPT and also GPT-4, which one is focused on the human alignment to give more human preferred answers and also reduce the bias of the model. And then the last one is focusing on combining different modalities as the input, such as the images as the input, so that it has more since the internet is also full of images, and humans also rely on images to extract the information. So that a really powerful model should take the different modalities of the data to make even better prediction in the end. So you see that the last paper published is March this year. So I guess another paper should come about soon based on this time gap over here. So it's really a year thing. So it should be like early next year. There should be another paper showing coming up. That's based on this sequence of time points over here.